Good afternoon, friends. I'm Dr. Deepa, Associate Professor, Department of Computer Science and Engineering, KIT Kalingar Karunanidhi Institute of Technology, Coimbatore. On behalf of our KIT Kalingar Karunanidhi Institute of Technology and Department of Computer Science and Engineering, I welcome you all for KIT Knowledge Series webinar, Data Science for Engineers. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structured and unstructured data. To emphasize this science, today we have Dr. R. Joseph Manoj, data scientist, Hexaware Technologies, Chennai. Dr. Joseph Manoj completed PhD in Computer Science and Engineering from Manonmaniam Sundaranar University, Tamil Nadu, India. He is having more than 18 years of experience in education and IT industries. Currently, he is working as a data scientist at Hexaware Technologies, Chennai. Dr. Manoj is a Microsoft and Tableau certified data scientist handling projects in banking and insurance domain. As a researcher, he has developed several research projects and published more than 25 research papers in reputed national and international journals. On behalf of our KIT, Kalingar Karunanidhi Institute of Technology, Coimbatore, and on behalf of all our participants, we welcome you, sir. I extend my warm welcome to all the participants who have shown the interest in attending this webinar. Have the wonderful session. Thank you, and over to Dr. Manoj.
Yeah, thank you for the brief introduction, ma'am. I would like to extend my thanks to your college management as well as the Department of Computer Science Engineering staff members, supporting staff members, right, who work on this live event. So, good afternoon, everybody. Hope you are all doing good, feeling good, right? So, as you know that we are in very tough situation we are in, and thankfully we have to thanks these technology improvement, and these technologies are connecting us virtually, right? And it let us to learn a lot, right? Of course, as a student, as a staff member, as a corporate employees, we learn a lot. During this lockdown period. Okay, so I'm happy to share my knowledge with you all regarding data science. I just move on to the slide. So are you able to see my screen? Are you able to see my screen? Hello? Okay, so let me start.
Yes, sir.
The topic we are going to discuss today is data science for engineers. As the topic says, data science is an art. You can use this art anywhere in your organization. So it is not only for IT industries. It is not only for any exclusive or specific domain. You can use this art in any kind of domain. So if you want to use this data science technology or technique in financial department or any other production department, okay, so you can use this data science concept anywhere. So let me share the second screen. So this is my plan today. In next 1 hour, we are going to discuss these topics, and especially about data science and how the ML model will be deployed as well as developed, and how this can be useful for you. So just everything I'm going to share with you. Of course, I know that there are so many interested candidates, participants will be there. There are so many students. So you are all aspiring data science field. So it is happy to share these things to you all. So first I'll start with definition. What is data science? The data science is all about the automated and machine-based way to extract meaningful insights from big amounts of data. So what does it mean? Extracting meaningful insights. So that is the main target of main aim of this data science technique. Okay. So extracting meaningful insights means what? Data may be anything, maybe any organization data or maybe your college data. Unknowingly, we may have so many useful information in this data. So how to get the data out? How to bring that data out? So that is what called as getting insight or getting meaningful insight from the huge amount of data, right? Otherwise, you can say it is a field of study dedicated to collecting, storing, analyzing, and extracting information about people, machines, and the wider world. So it's a high level definition of data science. Okay, and this is something I would like to share. So this is a data science. As I told you, it is an art which combines different fields. As I told you, this is not only the uh, field of computer science engineers or IT engineers, right? And here it is a combination of different domains like computer science, maths, and statistics, as well as domain or business knowledge. Okay, so you need a support of different person, right? Data scientist or as a data analyst, you need a support of different persons in this area. Okay, suppose if you are developing some simple application using Java or .NET, then of course the IT engineers all are joined together, and you can develop the use case, or you can understand the use case, and definitely you can solve the issues. On the other hand, this data science is not a problem like that. As I told you, you are given some amount, I mean huge volume of data sets, and from the data set you have to extract the meaningful information to the organization, because they will be using that insights for their business purpose, for improving their business they are going to use. So that is the thing. So data science is not only the role of, I mean not only the domain of computer science engineers, it is also mixed domains of mathematics domain as well as business knowledge. And this is a slide you have to must know about it. And next slide will be top data science jobs. What are the different roles we are having in a data science projects? You might have known about this data scientist. Is one of the main roles we are having in this data science project. Apart from that role, apart from data scientist, you may have so many roles like data architect, data engineer, statistician, data science manager, machine learning engineer, and decision scientist. So like that, we have many, I mean, different kinds of role. They are doing really different jobs in data science project. For example, if you take data architect and data engineer, so their role will be collecting the data, collecting some data from the cloud or on-premise data sources, and then just they give some shape to that data. So that is the role of data architect and data engineer. On the other hand, you take a statistician. Of course, there will be the so many statistical techniques, right? So many statistical techniques to be implemented in data science projects. So with the help of statistician, data scientists can solve their issues and can get some insight from the data set. And other roles like a data science manager, machine learning engineer, decision scientist, of course, they are also having different roles. And if you want to say specifically about machine learning engineer, so he is an engineer, he's playing a role in developing the machine learning model. Okay. Okay. So before learning data science, you have to know about data completely. Okay. So if you talk about data, because you are going to revolving around data, you are going to get the insight or extracting the insight from the data set, or a large volume of data set you are going to getting the insight. So you must know the data, what is data, completely thorough, right? So whenever, suppose if you want to learn data science, you must start with what is data, and what are the types of data basically we have, right? And then according to this slide, if you look at the left side, you have two kind of types of data: qualitative data and quantitative data. Qualitative data can be obtained by observing the activities, by observing the events. You can get this qualitative data. Again, that can be classified into two. One is nominal data, and second one is ordinal data. What is nominal data? It is a categorical data, like that. Suppose one column has gender name, a column name is gender, it has male, female, or you have a column name called as color of hair. You may have the values like brown, black, okay, some values you may have. So this is what called as categorical variable, right? So what is called as nominal data. And go to second one, ordinal data. Ordinal data can be ordered. Okay, what is ordering the data? For example, some of you ask you to rate the cinema, okay, or to rate the e-learning course. So what will you do? You will be giving some rating. Start with 0, 1, 2, 3, 4, 5. 5 is the maximum. So this is what called as ordinal data. 0, 1, 2, 3, 4, 5. So this is in the order. 5 is the best and 0 is a low one. This kind of data one column is having, then which is called as ordinal data. And come down, next type of data will be quantitative data. So this data can be obtained by measuring. If we talk about qualitative data, that can be obtained by observing the data, by conducting some interview, by observing some event. You can come to know that data. On the other hand, this quantitative data you have to measure so that you are able to get. So discrete data and continuous data. What is discrete data? I can tell you one example. Suppose I just store my exercise detail. Okay, day one I took 50 push-ups. Okay, in day two I just observed, measured 100 push-ups, and day three 150, probably. Okay, otherwise maybe one or two decrease, right? So you cannot say I take 100.5 push-ups every day. We cannot say like this. Okay, so that means the data cannot be splitted further. So that kind of data is what called as discrete data, right? On the other hand, continuous data, if you talk about, you can split it. For example, Usain Bolt, you all know that, right? So he reached the target, he won the prize. We will be saying that Usain Bolt won, okay, and his record will be 1 minute, 50 seconds, 10 milliseconds. So that this kind of data is what called as continuous data. Data can be separated, right? Can be splitted again. So you have to understand what is these kind of data thoroughly, right? So do not, should not jump directly into learning machine learning models and etc., etc. So that is a wrong way of starting data science learning path. So you have to learn something thoroughly, data thoroughly. What is data? What is metadata? What is information? What is scalar? What is matrix? What is vector? What is tensor? So many definitions you have to learn about this data. So that is a better one. And next one, what are the kinds of data you are going to handle? We will be handling in the data science project. Of course, you all know that structured data, semi-structured data, and unstructured data. These are the kinds of data we will be handling in the data science project. And I have given few examples for each and every kind of data, right? Structured data, all the RDBMS databases, you store student data, employees data. So that is what structured data, right? And the semi-structured data, we talk about XML, email, they are all called as semi-structured data. On the other hand, unstructured data, again, audio, video, images, so they are all called as unstructured data. And then come to the topic called as data science lifecycle. If you are new to this data science lifecycle, or sorry, data science topic, you please listen so that will be easier to move or to go forward, right? So there are so many phases in your data science projects. we have so many phases, right? So first phase will be business and technology planning. You are given a use case, and simply we cannot start as it is. Okay, writing not this is not right like a writing simple program. Okay, because this is a business, you are going to support a business. That's the thing you have to take care in your mind. Okay, maybe the big organization, okay, you are going to support, so you have to take care of the use case. What is the use case will be? Sometimes the domain will be near to you, then you have to go research, you have to research it, and or you have to study that, and then you have to understand the business. Otherwise there will be the subject matter expert, SME, right? So they will be supporting us to understand the business concept or business domain. You are given some insurance application, or any banking application, or any entertainment product application, whatever it is. Okay, definitely most of the domain we cannot we will not be familiar, so that we need the support of business experts, as well as we need to research it. So that is the first phase. You have to understand the use case, so that it will be easier to move forward. So understand the use case thoroughly. And next phase will be planning and prepare. What is plan and prepare environment in the sense? So of course you have understood the problem, and then based on the client's requirement you have to plan. Okay, what is the environment we are going to deploy? What is the tools we are going to use? Everything you have to plan in this second phase, what is called as plan and prepare environment. Okay, fine. And third phase will be ingesting data. What is this ingestion of data? This is the very, very important phase in the data science life cycle. Ingesting data in the sense you are acquiring the data. Okay, you are going to solve the business use case, and you are acquiring the data from different sources. You may acquire the data from another cloud, or you may acquire the data in on-premise cloud, or any kind of data format, right? So there are so many challenges you will be facing in this phase. So in this phase, there will be the data engineers, data architect. So they will be supporting to get the data or collect the data and store the data. So this is what we are doing in this third phase, called as ingest the data into the data platform. So data platform is nothing but where we store the data. So like that, just you assume it. And next phase will be explore and visualize the data. What is exploring and visualizing the data? Once you receive the data set, you have to explore it. You have to understand the data. Now, so far you have understood the business, you have understood what is the environment you are going to work, and now this is the time you have to understand the data where you are going to work. Okay, so that is what called as explore and visualize the data. So in this case, in this phase, you will be using different visualization tools, like you may use, right, Power BI or Tableau. These are the tools you may use. Of course, it is not mandatory to use only this Tableau and other visualization technique. Using Python or other tool also you can use to explore the data. So anyway, to understand the data, you have to go for this, right? And next phase will be generate and select the feature. Of course, that will be the number of features. If you extract the data from your cloud or somewhere else, you will be having number of features, number of columns. Definitely we will not be using these columns to train the model, to develop the model. So we have to understand which features or will be useful or will be used to in the model. So that's what we have to understand. We have to select that feature only. So here also we will be facing so many issues, right? How to select? So we have something called as feature engineering and feature selection process. So using that, you can select the features from these given data, from the given data set, right? So that data, selected data will be taken to the next phase, which is called as train and retrain ML models. What is training the models? Here you will be choosing the algorithm, right? Based on the use case, you have to select the algorithm, whether classification or regression, right? or clustering algorithm, or is there a reinforcement algorithm? So based on the use case, you have to choose, and then you have to train the model using the data set you have selected. Okay, once the model is trained, so that will be that should be tested. So whether that model is acceptable or not, you have to check the accuracy. If the accuracy is not good, again you can go back, right? That is what this arrow mark is given, right? Iterate on the model, right? So you will be go back, you can go back, and then you can select few more features, or that doesn't work, you can go to the business understanding phase itself, right? You can go the first phase itself, and then you can start re-engineering process again. So that is what you have to do to optimize your model. Once the model is optimized and acceptable by the customer, then you can go for the last phase called as deploy and consume the model in product. So these are the 7 different phases we are having in the data science lifecycle. So I think you can understand this. And just I'll give you the overview. I give you the overview of this machine learning. As you know that you have 3 kinds of machine learning algorithms: supervised, unsupervised learning, right? Then reinforcement learning, okay, semi-supervised. So like that you are having. Just I recall this algorithm. Each and every learning algorithm having set of algorithms. Each and every learning, right? Supervised. If you take supervised, you have classification and regression. Again, classification, they have number of algorithms. So take a unsupervised algorithm, you have clustering, then association rules, right? Each and every learning type will have separate algorithm. Again, reinforcement. What is reinforcement? So like that you learn, okay, and then if there is any error, again you will be correcting that, and then again you will be learning. So this kind of learning methodology is what called as reinforcement learning. I think you all know that what is supervised and unsupervised. Anyway, I'll repeat that. Supervised learning, in the supervised learning, the labeling will be given. The target variable will be given. What you have to predict. So that will be given in the supervised learning. So that is the target variable is otherwise called as labeling. On the other hand, in this unsupervised learning, so nothing will be given. Okay. If you want to say any example, if you take a supervised example, teacher teaches students. So he or she shows apple and tells this is an apple, and shows an orange and this is an orange, like that he teach. This is what called as supervised learning, and you have, and then they are labeling it, right? And unsupervised learning, nothing will be given. So just something will be given, and you have to learn that lesson or something. So that kind of thing is what called as unsupervised learning. Okay. So you can apply anything, or you can find the patterns, or you can group something, you can find the similarities. So any learning methodology you can apply, and then you can find the insights of that given data, so which is called as unsupervised learning. Okay, so this is something you must know. So there are so many machine learning applications, and these are the few areas I have given. We apply machine learning algorithms like virtual assistant, right? Intelligent agent or natural language processing. We apply social media, transport. Okay, there are so many applications. Each and every domain has financial series, healthcare, e-commerce. So there are so many applications, but I have limited that application as 7, right? And one more concept you have to know that MLOps, that is machine learning lifecycle management. What is this machine learning lifecycle management? I think you might have known it, right? So you deploy the model, and then you may think about that. So once the model is deployed, once the model is developed, then our part is done, or the data scientist part is done. So not like that. Okay. So development is done. Okay. After that, you have to go for deployment. So after deploying the model, you have to monitor it, because in real time, your model will be facing so many issues. Okay. In real time, your model will be facing so many issues, so that you have to monitor the model, whether the model is degrading based on the current data or real-time data, how it works, because you have trained your model in using different data set, right? And you have deployed it. In the production phase, or in the production of model, it will be using the real-time data. The real-time data, it may have varieties of things, right? So that you have to monitor. So you might have deployed that model using the accuracy 96 or 95 percentage. You might have you can, right? But once it is deployed, okay, it may decrease it. So that accuracy may decrease. Maybe 80 or 85, maybe 40 or 50, because of the situation, because of the environment. So that is the what the monitoring is needed. So complete process is what called as machine learning lifecycle management. Just you train the model, package model, validate the model, deploy it, and monitor it, right? If it is needed, you can retrain it. So that's what I have given a line below, right? Retrain model. Okay, again, you can start from their training model, packaging model. So this will be happening again and again till the optimization is occurred. So again, this is the process what called as continuous delivery, continuous integration, continuous delivery, right? If there is an issue, immediately it will be rectified, and then the model will be submitted again. Again, if there is an issue, again will be satisfied, and then model will be deployed again and again. So there will be no waiting period. So this kind of process what called as CI or CD. Okay, so how can you develop machine learning models? So there are two ways you have. One is custom ML, and second one is auto ML. Custom ML, as you know, that we use different tools like TensorFlow, PyTorch, NumPy, Pandas. There are so many libraries we use. And what is this auto ML? I think most of you not familiar with this one. No need to write code. Okay, so automatically it generates it choose the machine learning algorithm, and it gives you the output. Okay, just your part is you have to submit a quality data, right? So that kind of option is available. So that is what called as auto ML, right? If time permits, I can show you the demo on auto ML. Otherwise, I'll give you the demo on custom ML. So this is learning part of data science. So suppose if you are really interested to learn data science, because as I told you, data science has a lot of opportunity. Why I am saying this has a lot of opportunity? You will not depend only the IT industry, because each and every company nowadays started to recruit data science, say the data scientist, data science people. They take insurance companies, any insurance company take, they are handling volume of data, huge volume of data. Definitely they need data analysts, data science persons to be there, and they have to get some insight, of course, right? And if you take car production company, right, you take a Ford or Maruti Suzuki, any kind of type of company, they have their own data scientist group. So that's what I'm saying. You have huge opportunity in these data science, right? Each and every organization has data, right? Huge volume of data. Then of course they need to extract insight of data. Definitely they will recruit data science people, right? So how to learn, where to start? So immediately, as I told you, you should not jump to second step, third step, and fourth step. So that is a wrong thing. Definitely you cannot learn completely, or you cannot learn properly. So this data science, so you anyway you need some prerequisite, right? So you need to learn statistics. First of all, statistics is very, very important to this data science field, right? You have to learn each and everything. You have to start from what is statistics, what is mean, median, where to we apply. Learning mean and median is not, doesn't matter, but what is the inference you will be taking? What is quartile? Okay, 25 percentile. What is 50 percentile? What is the use of that in data science? What is the inference we will be getting? What is the visualization? You know, all of you know the pie chart. Okay, from that pie chart, what did you know, or what do you know? What you got as a insight? So this is the thing you have to bring out. Okay, learning pie chart, I know how to drop. Okay, that doesn't matter, but thing is you have to think, and you have to get the extract the insights. So that is matter, right? So you must be thorough on it. You know SQL, statistics, and core Python. This is what the prerequisites. Okay, I'm talking about Python learning path. So this is the first step. Once it is learned, right, and then you can go to the second step. You can learn what is NumPy, okay, Pandas, and then scikit-learn, Matplotlib. So these are the next step, right? This is the next step that you can have, right? And then third step is some advanced libraries like TensorFlow, Keras. like deep learning concept you can learn. And finally, for last step, you can learn some real-time, streaming data, how to handle streaming data, how to handle big data in your data science. So that you can learn as a final step, right? So this is your data science learning part. And I just would like to just take you these things. Okay, suppose if you are really interested, you please, I just refer these books, right? Business Statistics by Ken Black, and this is a wonderful book, and you can use this book to learn statistics, and based on that you can take decision, okay, in your data science projects. And if you take a next one, machine learning, this book is not dedicated to any programming language. Okay, it will not it is not based on any programming language. It gives you how that algorithm works background, okay, behind the screen. You know how to write the logistic regression. So we have a function. If you use that function, and then what are the parameters you have to supply it, and then you can build a model. You can set the accuracy or get the accuracy, whatever it is, right? But how the logistic regression reads the input and how it produces output, that should you have to learn, right? Suppose you take a next one, linear regression model is how linear regression is work. What is called y is equal to mx plus p, how that equation is work. This is what you have to learn before understanding or before learning any kind of machine learning, right? So this book will help you to understand that one. And other two things, data camp, I just suggest this is a e-learning portal. You can learn something very good data science courses. And of course you must be in LinkedIn. You please join LinkedIn. If you are interested, you please join with data science community. They will be posting many updated information what is going on nowadays. You can see so many use cases, so many applications, you will come to know that. So it will make you complete data scientist in the particular field. Okay, so now I'll go to the demo. Okay, so we will be seeing two demos. One is a custom ML development. Another one is how to deploy that model in the cloud. So this is what I'm going to show you. It's time 3:30. I'll start it. Okay. I think, are you able to see this screen, ma'am? Hello, Deepa, ma'am, are you able to see this screen? Okay, that's fine. Okay, so what is the model we are going to develop is I'm going to predict churn. Okay, churn prediction. What is churn prediction? Customer churn, right? We are in a tough situation, right? COVID-19 issue. Suppose one organization want to know whether this customer can retain, okay, till 2020 or next month or August, September. So that organization want to know, okay, because of this tough situation. So this is what the use case given to you. This is what called as customer churn prediction. Okay, and the data set given to you is, so I have taken a simple data set, and it has of course 14 columns, right? And it has 10,000 records, right? And if you talk about the column names, row number, customer ID is there, surname is there. So this is what the phase by phase I'm moving, right? So you please follow me. I'm going based on the data science life cycle I have explained you. So now we are understanding the business use case. I think you have understood, right? So problem is customer churn prediction. So whether the customer can be retained, okay, next month or tomorrow or till 2020, end of 2020. So this is the use case. And if you are having any doubt, of course you have to research, you have to study it, or you can ask subject matter expert who is customer and which kind of customer they are. So many questions you can ask, right? You have to ask as a data analyst, you have to ask this kind of question, right? What kind of customer is, so what kind of product they purchase, what kind of company is that. So many questions we can ask. So anyway, this is the thing you have to know. And then second step is, of course, your client says you have to deploy this model in the cloud. So this is the constraint client has given to you. So first phase is done, and second phase is you have understood your environment, and third phase is getting the data. You have got the data. Okay, client has given the data. Okay, if the data is not available, of course client will give their data warehouse access. So from the data warehouse access, using that access, you can download the data, and then you can make use of it. So that's the time, the data engineer will play an important role, and they will be supplying you the data. Fine. So now we have the data, and what we are going to do is, this is what I mean. I think you can see the last column, exited. Okay, this is what called as target. Okay, this is the historical data an organization has given, right? It has customer ID, customer name, and then their credit score, and their geography, their gender, age, their tenure, balance, number of product they have purchased, whether they have credit card or not, and they are active member, and then their estimated salary. So these are the variables, features they have given. And also they have given the last column, that is called as exited. But what does it mean? You take a Hargrave, right? So he's a person, he is exited. One means yes, okay, he's no more with the company, right? And then you take a second person, okay, he is having these values, he remains, okay, he is with the company, right? Again, you take a Onyo, he is no more, right, with the company, okay, he's, and then Boni, right? So like that, these values are given in the last column. Okay, so this is the historical value. What we are going to do, we are going to predict the same thing. Okay, suppose customer gives customer name, credit score, geography, gender, everything up to estimated salary, he will give as input, and your model has to say whether that person will be remain in your company or will exit. Okay, what is the chance? What is the chance, right? So that is the model is going to predict. I think you can understand what I'm saying, what is the use cases, right? So here clearly it says it is a supervised learning algorithm, because your target is very clear, right? You are going to find out whether the customer is will be exceeded or not, right? So that is what you are going to predict. So that definitely it is coming under supervised learning algorithm. And again, you can have two more categories here, classification and regression. Here, since it is a categorical variable, right, you are going to predict only 1 or 0, yes or no, right? So that is what you are going to predict. So classification algorithm will be suitable for that. So this is what the first information you have to collect from that, right? So this is the data, and what I'm going to do is, and just I'm going to develop a model for this, right? And what is the model will be talk about? Okay, so this is something, what the interface. Okay, just listen, it's very important here. Okay, I give some value, I'm giving some value, I'm not giving customer name because that is not needed for us, right? And I give balance, okay, and then credit card, he is having credit card, active member, and what is the salary, and he's which country he belongs to, right? Everything I give, everything, right? Once I click yes, then your model will be giving the output yes. Okay, so as a client, you will not come to know that. But what happens here, I am running a model behind this application. Okay, so how this outcome will be generated. So that is a model is running. So that's what we are going to do. How this model is developed and how I deploy this model in the cloud. That's what I'm going to explain you, right? So that's fine. I go to the Jupyter. I think you all familiar with this one, and this is the IDE we use for Python programming, and this is the IDE I'm going to use now, and I'm going to write the program for that, right? What's the time? Okay, 3:40, right? Still 20 minutes more, right? Okay. So again, I repeat, The problem is customer churn prediction. So just include whatever the libraries or whatever the packages you want, right? So you use it, and just I have included this Flask. I'll tell you why the Flask is needed, why I have included, I'll tell you later, right? And then I just start my exploratory data analysis. As I told you, after getting the data, you have to understand your data very well. So that is the reason we go for this exploratory data analysis. So what I'm doing here, I just load the data where I store my data, churnmodeling.csv. This is the file where I store the data. I just load the data to my data frame called as df. This is the first step you have to do, right? And then there are so many comments. Okay, so if you want to pin the first 5 data, right, you can use head, right? Otherwise you can have tail, right? So these are the commands, right? So like that you may use different commands. So since I have limited time, I'm not able to explain each and everything, but I just go through each and every command what I have used. They are all basic command. And then you have one more statement called df.shape. So this is to give your number of records as well as number of columns, right? And next one, info function. This is another one important function in program, I mean data science application. So what is the output of this info function? If you see, it gives so many information regarding your table, right? If you look at this one, first one, what is the range? 0 to 949. So that is a range you have, I mean 10,000 entries you have. And of course you have 14 columns, and it talks about each and every features or columns in your row. What is the data type, and whether that has any null value. According to this row number, it has nothing, it has no null value, because 1,000 entries, it has 10,000 non-null, so there is no null values. Again, customer ID, surname, everything. Okay, if you look at each and every feature, they have no null value. So this is the inference you will be getting from this info function, right? And look at next one, describe. So describe is a function to get the statistical information of numerical columns, right? Will not be applicable to string. Okay, so if you look at this geography and gender, so they are all these two columns are having string values. This column will not be applicable, right? So not applied in this geography and gender, right? So if you look at, you may think like this, okay, whatever, okay, but here you can get so many information. If you use describe, you can get so many information from them, right? I just take this age. I just take this. This is what called as data analysis. Okay, this what we are doing, data analysis, or we are doing exploring the data. We understanding the data, right? This is I think fourth phase of your data science life cycle, right? You can understand any manner. You can understand so many processes. You can do so many commands are there. You can group it, or you can split it. You can apply so many things. I can suppose here I'm having, okay, country wise, if you want to analyze something, you can do that using group by function. You can do that, or gender wise you can analyze. Okay, you can do that. Or if you want to analyze greater than 25 age, okay, age is greater than 25, then you can do that. So many analysis you can do based on your application, based on your requirement, right? So I'm in this, okay, this cell, right? What this cell talks about here, what we are doing. So this is, you see here, what is that total count? Okay, what is this each and every column having? What is the number of count, and what is the mean value of each and every? Okay, if you take this age in this data set, average age, okay, average age is 38. Okay, like that you can say. Then again, if you take a estimated salary, and I think this is right, almost 1 lakh, right? 1 lakh, that is the okay, mean value. So like the standard deviation, what is the minimum value or of age, of tenure, of balance? And then this is not a 25%, 50%, it is a quartile. 25% means otherwise quartile 1, 25 percentile. So like that you have to call it, right? And what about this one? So what does you mean about this one? Okay, that means first quartile, the maximum is 32. Like that, you can conclude this is the insight you will be getting from this, right? And if you take a second quartile, 50 percentage, and then that will be the 37. That means 25 to 30, 25 to 50. 33 to 36. Okay, so that is the range of data you are having between 25 to 50. So this is what insight you will be getting from this describe function. This is applicable to each and every one, tenure, balance, everything, all columns you can apply, and then you can get some insight from this one. Okay, this is another one analysis. Okay, and I give you one one insight from this. Okay, if you look at this one, if you look at this last four of age 32, 37, 34. So 32 plus 5, 37, 37 plus I think 7, 44. So something you can see the distribution, even distribution is there. On the other hand, if you look at 44 and 92, so the distribution is not favored to us. So 50 for 44, about 50, so you will be getting 92. So that will be the problem. So definitely the accuracy will be reduced. Okay, reduced in the sense it will be the one of the factors. Okay, it will may reduce your accuracy. Like that, you can check each and every column. On the other hand, if you look at this one, 3, 5, 7, 10. Okay, so it is very good. It is distributed very properly. So how can I say? So this is something skew, right? What is the function of this skew? Suppose the value is 0, that data is distributed normally. Okay, so as I told you, this tenure 3, 5, 7, 10, each and every quartile, the range is very the ranges are properly distributed, right? On the other hand, if you take this one age, as I told you, 1, it is it is not distributed normally. So like that, you will be coming know different information from that, right? Again, you can use so many visualization technique. As I told you, this distribution, age distribution is not proper. Okay, so again, you can use scatter diagram to find the relation between age and balance. So you can use any kind of column name here, right? So again, pie chart I have used, right? I taken France, Japan, and Germany. So these are the 3 regions we are looking for, and how they are distributed: 50, 24, 25. This is the data, right? We are having France data. 50% of the data belongs to France. So this is something you can get it. Okay, and this is another one visualization technique to find the outliers. Okay, if you look at this one, this is a box plot. It is very well useful to find the outliers, right? So these points are outliers, right? So this is what called as a 25 percentile, and this is minimum, and this line is median or 50 percentile, and this is 75 percentile, and this is maximum 100 percentile. And after that, you will be considered as that is a outlier. So this outlier will give some impact on your model accuracy. So something you can get to know that, right? If the accuracy is less, then you can come to this point, and then you have to correct this outlier. How to reduce this outlier, you have to take care of it. So that is what. Okay, and next one is, this is correlation graph or heat map. We will be saying this talks about how each and every column is related with each other. So that is the thing it talks about. And this is your target variable exceeded. This is what you have to find out, how other variables are related with this one. Okay, so the relation is very less. Comparably, compare with estimated salary as well as exceeded, then their relation is 0.012. And again, exceeded with is active member, see minus negative. So in a very less relation they are having. So like that, you can compare all the values, okay, each and every values with your target variable, how they are related. So based on that, you can choose. For example, you see here 0.29. So this is the relationship value between age and exceeded. So this is the good one. Compare with others, this is the good one. So they are bonded with each other very strongly. So that means this age will be giving impact to the exceeded, to predict this value very correctly. So this is because other values are very less compared with age. Okay, so this is the insight we have got, right? So this is what we can say exploratory data analysis. You can continue so many things regarding this. They are based on your application, based on, if you are if you have not understood well, then you can go further and you can use so many techniques and you can understand your data. So what is called as data analysis. So okay, what I'm doing, I just go to directly to the machine learning building, and I have built a model, I have completed, and then I use a random forest tree, and then because as I told you, it's a classification algorithm, I have used random forest. Okay, then see, this is a statement. I split the data. Okay, I split the data here. Train, test, split. I split the data into training data set as well as testing data set, right? And next one is I just initiate the object for the random forest classifier algorithm. So that object name is called as classifier. And then here I give how many number of trees I have to get, and what is the depth of each and every tree, and then random state, how that has to select the data set values randomly. Everything I give, and then so if I give this, and then I fit it, I just say train the model. Okay, I just take this object or variable and then classify dot fit, and then I supply my training data set as well as y train. So here this y train is the predictor, right? Sorry, target value. Okay, so here you will be having that values of exited, right? And here you will be having other values like customer name, id, then next salary, everything other than exited you will be having in this. Okay, so it is this, your model is getting trained using this one. Okay, and then next one is you are predicting using the test, because you are splitted already, you have splitted already. And then here you see x train, y train. So this is x train, y train is, they are the training data set, and x test, y test, they are for testing data set. So I just take this x test and take it here, and then I finally I get some output, right? And then for this given test data, and I get some output, and this is the output. Just I'll give you some clarification on it. If I give print statement, you can get something, right? Okay, if you look at this one, for the test data 519, 35 up to 0, it has given the value 0. I mean, this person, okay, will not exit your company. So that is the outcome. That is what it has predicted. And the second one, if you see, again it has given 0. That means that again that person will not exit. So this is the manner. And finally I have got some accuracy 0.86. So as I told you, why this accuracy, I can tell you. You see, this is the feature importance graph. The model has given importance to age feature. Okay, as I told you earlier, age is not distributed normally, it has skew, right? So that does matter. That's one of the factor it affects, which affects accuracy. So if you transform that values, I showed them some outliers. Okay, if you remove that outliers or if you transform that outliers, then definitely you can get more accuracy here. But I have not done that optimization techniques here, right? And this is something classification report. It talks about how many number of yes predicted correctly, right? And then false predicted correctly, everything it talks about. That is what classification report. Classification report is one of the performance metric, otherwise this confusion metric, right? So it's one of the performance metric which can be useful to the classification algorithm, right? So that's what I have used here. And if you are using regression algorithm, you have to use some other measurement technique like R square, squared R, then RMSE, MSE, like that. You have so many metrics available, you can use that one. Okay, fine. And then our model is ready now, and its accuracy is 0.86. So now the development phase is done, model development is done. Now we are going to deploy the model, okay, in the cloud. So that's what I'm going to show you. And before that, I just would like to show that one. So usually we will be generating an exe file. So same manner, this model, classifier model, will be generating its pickle file. Okay, .pkl file we have to generate. So for that purpose, you need this library, sklearn externals library, and using this job lib, you will be creating that pickle file .pkl. it is same as exe file. Okay, like what we are doing. Okay, you write a program, and then finally if it is running, you will be converting that into in the exe. That exe will be taken to the customer side, that will be executing that. So same manner. So now this is your object file or pickle file for your model classifier. So no need to take this source code to the program or cloud. So only thing is you have to take this pickle file. That's what I want to show that one. Fine. Okay, so now I'm going to show you the next phase. That is, I'm going to deploy this model. Model is ready and pickle file is ready. I'm going to deploy it. And then of course I have designed one user interface. I have showed you user interface where I read the data, and that data will be passed to this file, and then this model will be giving the output. So that is what already I have shown it. And this is something. Okay, I think you can see this one, right? What is called as Microsoft Azure Cloud Platform. This is okay, where we are going to deploy our model. So we developed our model using Jupyter Notebook, and we found accuracy is very good. And then after testing is done, and then we are going to take that model inside the cloud. So that is what I'm going to explain. So already I have completed that one. So that is what I showed this output, right? How it works. I deployed it, and then I have got this URL, right? So this using this URL, I just showed this output, how it runs output, right? Anyway, I'll be showing that one very clearly, how the deployment will be done and what are the steps you have to undergo. See here, one by one, you please follow me. So this is the first thing you have to go, right? Create resource. Okay, create resource. Then here you have so many services like a Windows Server. If you want to create a virtual machine or SQL database, so many services are there. And what we are going to do, we are going to select web app. Okay, this is the thing I just do. Okay, it takes time. I don't know what happens here. It takes time. Okay, fine. So this is the first thing. Okay, so I'm using free trial, free subscription. I mean, so that subscription is free trial, right? And then you have to choose what is a resource group. Any one of the resource group you have to choose. If you want to generate a new resource group, then you can choose this create new. Otherwise, you can have the existing one. So what is resource group? Where you can have related documents, right? Here you are going to deploy something, and then that will be taken to this resource group, and related documents you can get it into this, right? And next one is what is the web app name? What is the URL name you have to give? That will be extended like this. Okay, if you look at that one I showed right now. Okay, it's not open, right? Anyway, you can give something. Okay, I just shun web. Okay, like that I give. And then it asks you whether code or Docker container you want publish. Okay, I don't want to go with Docker. I just want to deploy the model using my code. Okay, I just select that one. Okay, and the next one is select a runtime stack. What is stack? What is stack? Just we have used Python, right? Python is the language we have used to develop the model. So that's the reason I have chosen this Python 3.7. Suppose if you have developed a PHP using PHP or Node.js or Tomcat, then you can choose accordingly, right? So here this is Python 3.7 is a correct one. Okay, and then next one is region. What is region? Which region you are going to publish, right? You may have number of different region. Like if you want to choose our region, like Central India, okay, you can select it. Otherwise, East Asia, okay, you can go with that, right? But I'm not changing that one. I use just Central US. Okay, so that's all. Other data I just leave as it is. Okay, now I click this button called as review and create. So this is the first step. And what I did, I choose I give this resource group name, and then I named my web app, right? And then what is the stack I chose, and then finally I click this review plus create, right? Okay, so just it is running, and in between, okay, it has come, right? Okay, fine. And then some information just report it generates, and finally you see here, this is the icon create. Okay, now you click this create, and you see here initiating or initializing the deployment process. Still we have not given our code, we have not taken our code here, but just we have instantiate the web app, so our deployment is underway. In meantime, I'll show you one more thing, right? I think you all familiar with GitHub, right? So I have taken all my code here. Okay, what is the code? See here, this is the Flask code I have written, right? So using the Flask only, I'm going to interact. I mean, this I have written this HTML file. That files are deployed using this Flask. Okay, as I told you, this is already created one, and then I take this pickle file here, and then this is the home which HTML page, what has to be done, and then it reads all the values from the HTML page, and then it applies predict. Okay, you see here predict, and then predict values here, and then finally we get the output. And you see here, okay, if output is 1, it says yes. Okay, if the output is otherwise, it shows no in the result HTML. Okay, so that's what I told you, I'm using ML model to bring this output. Okay, so what I'm doing, you in the GitHub, I just stored this Flask file in the name of app.py. No need to store this file, no need to take these files, right? No need. Just store this app.py and your pickle file, chun predict.pickle file 1, 2, and then your HTML pages, home HTML and result HTML. So these are the files you have to upload previously. Earlier you should have uploaded in the GitHub, because from this GitHub repository I'm going to take my data, right? So now the deployment is complete. I'm going to link that code with the Azure, right? Go to resources, and you go to deployment center is here, and you click on it. Okay, so there are 3 steps in the deployment center. It asks you, you see here, it asks you which repository you want to choose. Okay, GitHub, because if first time, if it is not authorized, it will not be authorizing you, right? So you have to authorize. That means you have to click it, and then you have to give your GitHub username and password. So here already I have this is myself authorized, so my name is here, right? I just choose that one. That is my repository I'm going to fetch. And next step will be just I continue. Okay, you see here, this is something you have to understand. Okay, this is organization name. Organization in the sense, this is okay in GitHub. What is my name? RJ Mono 79. This is my name, and then this is what shows here. And then here you see repository. In the repository I have so many things are there. Okay, if you see here, I can show you something like different codes I have. Okay, see, these are all okay, all the directories will be displayed here, but my folder is chun predict ml. So where I have stored my app.py and then pickle file, HTML file, and then automatically the branch will be selected. Then I just okay, so I finish my deployment. You see this side setting up deployment. No, now it takes your code, into the cloud. Okay, now you have connected. You see here your source repository GitHub rjmanoj chun predict ml. Okay, so it is going again fetching deployment data. So it will take some times, and then finally, as I told you, it will be generating, it will be taking you to this kind of page. Okay, so in that page, after deploying successfully, it will be giving this page, so where you will have a URL. So once this URL is clicked, and then oh sorry, okay, so still that is not completed. Anyway, so it will take you to that interface. So I showed first of all, right, HTML pages. It will take you that area, right? I'll check once again. Okay, fine. So now it is running. See, So it takes you, and then I give you all the values to be passed to the model, right? I give you all the values: credit card holder, active member, and what is the salaries. Just randomly I choose, okay. And once it is German candidate, then you give other values 0. I submit. Once I submit these values, okay, in the page value will be taken to the model, and then that model will be giving this output, okay. So if I give this if I give this URL to you, you can execute this model, okay. Not only me, okay, this is applicable anywhere. Anyone can execute this model using this URL, right? That's what the beauty of cloud. I think you have come to know that how to develop the model, how to deploy the model, right? And so I think my part is done. And if you have any questions, please. I've taken 10 minutes extra. Yeah. What is overfitting and underfitting of data set? So I can give you one example. Okay. What is overfitting? Okay. Angir Kani, I'm answering to Angir Kani. I think, I don't know, you are a student or not. Okay. Anyway, I assume that you are a student. Okay. You prepare your exam using your past 5 years data questions or 3 years questions, right? If the questions are asked, I mean semester examinations questions are asked within this 3 years question, then you can answer very well. Am I right or wrong? You can answer it very well. Suppose that question, I mean semester examination question, is nowhere in your past 3 years of question paper. What about this situation? So which is called as overfitting. Okay. You are trained with a specific data set, but if you are going into the real-time data, you will not you are not good to answer that one. That is what overfitting. What is underfitting? In the sense, of course, the data is not enough. Okay, data is not enough. Something, you have 5 units, right? 5 units. You are learning only 2 units. Okay, what about other 3 units? You have not studied. If you go to the right exam, what will you do? Definitely you are not able to answer that one, because you are trained only for first 2 units. Okay, so this is what called as overfitting and underfitting. And of course, you have some optimization technique, like regularization algorithms are there, optimization algorithms are there, and you can apply it. Otherwise, to avoid overfitting, you have to improve the data set. Okay, you have to improve the training data, then you can avoid this overfitting and underfitting, right? Okay, fine. For development Azure, okay, Whale, right? The question is, for development Azure is the perfect one, or else we can go for DigitalOcean or AWS, anything else? Any suggestion, please? Yes, of course. Whale, there are so many ways of implementing model. I have shown you, based on this is serverless model I have shown you, right? In Azure itself, you can use it. You can use a Docker or virtual machine you can use, so that is available. And then if you take a AWS, again you have, options are available, but thing is, the EC2 concept you have, you can implement EC2, and then using EC2 you can available. But the simple thing is, you have to install putty, and then you have to sync private key as well as private key, public key. Then you have to execute some command to link your GitHub. So that is a matter, but no issue. So I won't say Azure is the best one and DigitalOcean is the best one. I won't say. Each and every cloud platform having their own pros and cons, right? So if you are good in AWS, okay, you please go ahead, right? So because I have learned so many things using Azure, so I'm familiar with Azure, I can use Azure. Otherwise, one more thing, in real time, if you talk about it depends your client. So sometimes a client will say, this is the cloud you have to implement, because they will be having some subscription in that. So that time you cannot argue them. So what depends upon the client, you have to go for. Yeah, that's a Azure and AWS ML deployment. I think each and every one is having pros and cons, right? deployment service will be differ. As I told you, in Azure you have the concept called virtual machine. So one of the deployment technique, Docker is there, and then serverless computing. So 3 techniques are there. You can use it. You can use that. And of course, if you take AWS ML deployment, very well you can use EC2 concept, right? You have some services like SageMaker, machine learning, right? You can develop your own program, and then you can create endpoint. Deployment in the sense, it all depends your subscription. Okay, the difference between Azure, AWS, all depends your subscription. Suppose if you take Azure, you will be having only 1 month valid subscription. Okay, free tier is only 1 month valid. On the other hand, if you take AWS, it has 1 year valid. Okay, the validity is 1 year. And one more thing, you cannot create number of instance. Okay, model instance, you cannot create a number of instance. So that is the drawback in AWS. So otherwise, no issue. It depends your subscription. If you pay and use AWS, you can enjoy so many services. That's it. Same manner, if you take Azure, if you pay and go subscription, if you use, then you can have so many services, and you can enjoy your thing, right? So in both AWS and Azure, they are having their dedicated services to watch, to monitor their monitor model. Okay, next one, Tirumurthy. Custom ML or versus auto ML in data science career point of view? Okay. Which one is better? Of course, custom ML is better, Mr. Tirumurthy, because I can show you the demo in auto ML. Auto ML can do, anyone can do this auto ML part. Sorry. Auto ML part, can anyone do that, right? No need to write code. Okay, but because of time is not permitting, otherwise I can show you the auto ML part, how that will be working. If you take h2o.ai, just you explore. Okay, after this session, you go and explore h2o.ai. So it has 21 days trial version. If you look at that, just you can import data. That's it. Okay, no need to choose algorithm, no need to anything, no manual work, right? Just to upload the data set, and what is the test data set you have to upload, and what are the columns are dropped, everything you select, and then you run. That's it. So system will choose its own algorithm, and it gives you the report. So your question is career point of view, custom ML is the best one. Okay. And one more thing, client will say you. Okay, client will say you sometimes you have to use auto ML. Okay, then no choice, you have to go with auto ML. Okay. Yeah. Anita Ponraj, when we need a good accuracy in medical data set, which algorithm will be better to analyze it? The question is fine, but I'm not, I cannot understand what is the use case you are going to solve. Medical data set, using medical data set, you can do so many things, right? Suppose if you ask me, take a ECG data set, right? ECG data set, and if you want to optimize ECG data set, I can say deep learning is the best thing, right? So it is based on the data you have, and based on the use case you are working with, the algorithm will be different. Any questions?
Thank you, sir, for wonderful session. Hope all the participants have gained some knowledge in the field of data science. I request all the participants to fill the feedback form that is available in the scrolling and description below. I take this opportunity to thank the management of KIT, our founder chairman Thiru Pongulurian Palnisamy sir, our vice chairperson Mrs. Indu Murugesan ma'am, principal, vice principal, deans, HODs of various departments, faculty members, and technical team of KIT Infonest for their continuous support in making this webinar as a successful one. I thank our resource person, Dr. Joseph Manoj, data scientist, Exaway Technologies, Chennai, for his excellent and informative speech. I thank all the participants for your response for this webinar. Thank you once again. Thank you.